Alright, so today we're gonna talk about the inverse of a function. So we're looking at functions. This is the last thing that we're gonna do in functions, the inverse of a function. So remember we did relations function with graph. This was the last thing we had to do. So guys, we have an inverse function. The inverse of a function reverses the process of an original function. So let's say we had a function that was considered to be f of x. So this is my original function f of x, and let's put a value to this. So let's say for this function it's equal to x plus 5. Now if I have the inverse of a function, it's written like this. So f to the power of -1 would be the inverse of function fx. Alright, so if I was to reverse this process, instead of saying x plus 5, I would say, what would I say? X what? What's the reverse of adding 5?
X minus 5.
Correct, x minus 5. So this is the inverse function here. Okay, so this is a very basic function that I'm showing y'all, but just to show you the concept. Okay, so with this one, we can put an input in and get a particular output. Okay, the inverse function would allow us to use the output to get back what that original input was. So for instance, let's say we use the input for f as 3, which is equal to, now I can say 3 plus 5. My final answer is 8. Okay, so now let's pretend that we didn't know what this was here. So let's just say we had a particular function fx which is equal to 8. So in this case now, here is my input, right? And here is my output. And let's say I did not know what the input was, but I have the output. Okay, so I have the output. I can use this and solve for x. However, if I wanted to, if I was given the inverse function, I could actually use the inverse function to calculate what my initial input was. Alright, so in this case, I know that the output for this function was 8. So let's use it as the input because we're trying to reverse the process. So because I'm trying to reverse the process, I'm looking at the output I got, which was 8. So when I put it inside here, I'll have 8 minus 5. So 8 minus 5 is 3. Does that look familiar? Alright, so essentially, when we have an input and we place it into a function, then we would get the output. Now, if we need to go back, we could take the output, put it inside the inverse of the function, and we would get our original input. Okay, so the input, if we put the input into this function, we get a particular output. If we put that output inside of this function, which would become the input for the inverse, we would get the original input for this one. Alright, just like we saw here. So the original input in this case was 3. Once we put it into this function, it came out as 8. So we took 8, put it in here, and we got back 3. Alright. So in essence, this inverse here reverses the process of what this function did. So that's why we can get back the original value when we use the inverse function. So take this down and then we'll go through some examples, some basic examples for y'all to identify, and then we'll go through the process of how to determine the inverse of a function. Alright, so what I want y'all to do is to determine the inverses of each of the functions below. Okay? So, what is the opposite of subtracting? What is the opposite of multiplying? What is the opposite of dividing? What is the opposite of squaring? Let's see what y'all come up with. Alright, so let's go through them. So, the reverse or the inverse of x minus 7 would be
7 plus x.
7 plus x or x plus 7. Now, this here is 3 multiplied by x. What's the opposite of 3 multiplied by x?
Divide.
Divide, lovely.
So x over 3.
So x over 3. All right. Okay, so that was just a little eye opener there for you guys, right? So then this one here now, what's the opposite of x divided by 5?
5x. X.
5x, which is 5 multiplied by x. And the inverse or the reverse of x squared would be what? Square root x. All right. So just in case you did not have this, just take this down. All right. So what we did here, these were straightforward questions. Now that we know the answers, I want to go through the process of what we would actually do to show our mathematical process to get these functions. So let's start with question 1. All right. Now, the first process we just do, we say 1, let's call it A. First thing we do is A, let y equal f of x. So essentially what this means is y represents our output, as we say. Okay, so we know that y here represents the output. So y here represents the output. Now, since we know what y is, which is fx, that means that y is also actually equal to this x minus 7. So therefore, I would write y is equal to x minus 7. Now, the thing is, this basically says output, and this here would be my whatever I would have put into this function, which would have given me y. Now, remember, since we're reversing the process, we want to make the input x the subject of the formula. Y is the output, we want to make x the subject. So right now y, the output, is the subject of the formula. So we want to reverse it and make x, the input, the subject of the formula. So the first thing we need to do to get x by itself is what? What is stopping us from having x by itself right now? So what's happening to the x now? What's going on with the x here?
It belongs to, like, it goes with the minus 7.
Right, so minus 7 is here. So how do we get rid of the minus 7?
Replace it with y. No, replace
What's the opposite of minus and 7?
plus 7.
Plus 7. So we add 7 to both sides, right? And what would happen to this once we add 7?
0.
0. So these basically cancel out, right? So then we would end up with y plus 7 is equal to x. So what this is saying to us is that once we add 7 to the output, we're going to get back the input. Okay? Because remember, from this question here, x was our input. And then we put it inside of here now again, when we did the question earlier. And we got it back. We add 7 now to the output, and we would get back our input. All right. So in this case here now, since we have it like this, what we do is we interchange now. We can say now that y plus 7, if we had to put the inverse, and we was to put whatever y is, so say whatever y is, would basically give us this y plus 7. All right. So since it would give us this y plus 7, which is this, so I replacing the x with this here. So now what I want to do is turn it back into this. So I'll interchange this y with x again, just so I could have it written like this. So this case now I would say f inverse x is equal to x plus 7. All right. So this is a process that we follow here to get to this part here. Okay, now I just showed you each and every step here, but really and truly we can go from here, interchange one time, and just end up having this step right here. Okay, but I just want y'all to see how this was. All right, so take this down. We'll go to one of these here again. So question, you could try question 3. show you all that process. Then I'll give you all 2 to try on your own, 2 new ones to try. And then we're going to get into the real, more challenging ones. So this here is the baby steps. This here is to just get us to understand the process. All right. So then we start off again here. Let y equal hx in this case. So therefore I would be saying that y is equal to x over 5. All right. Now I have y here, and opposite of dividing by 5 is multiplying by 5. Okay. Another way we could think of it is as cross multiplication. So you could almost say, okay, let's put y as a fraction. Anything as a fraction is itself over 1, which is equal to x over 5. Now I can cross multiply, so that means y times the 5 and x times the 1. So I'll get y times 5, which is 5y, is equal to x times 1, which is x. Okay, so now I have this here now, so I can basically interchange now and say, well, if I had a function like this y, which is 5y, this inverse is basically gonna end up being like this when I interchange, which is the opposite, right? So instead of f, I had to put h. All right, so since we had h as a function, we're gonna have h inverse, which is equal to 5y. Now we're gonna just replace this with our x, so x interchange when we get 5x. So that's our answer to this question. So basically, this here is the answer to this question here, but we just show the process of how we go about doing it. Now, once we do more advanced stuff, you're going to need to use this process to help you. But for now, this is just for you to understand what the process is like, especially the interchanging parts of it. So I want you to try to determine, and let's call this question 5. I want you to determine the inverse for this question here, which is f again, but it's a new f. So fx is equal to x plus 9. All right, let's see what y'all do for this. All right, so let's go through this now. So then we're gonna say step by step. Let y equal fx. All right, so nothing fancy here. Then all I'm gonna say is y is equal to x plus 9. So I'm even gonna make it shorter now for you guys so that you can see now that you have the process in mind. So we subtract 9 from both sides. So we'll end up with y subtract 9 is equal to x. Alright, so then now you could go straight to the next phase if you want, because now x is the subject. We could just go straight to the bottom where we interchange and we say x is equal to, instead of y minus 9, we say x minus 9. Alright, so that should help to give you a little quicker and better way to get this done. Alright, so you could take this down now, and then we're gonna go through the next level of this process. Alright, so let's say we had a new one now. So this is the next level. So this is our next level of, let's call this level 2. So we just came off of level 1. So then let's say we had a function f of x is equal to 3x minus 5. And then we're going to have a similar one that's going to be g of x is equal to 4 minus, let's say, 7x. Alright, so we want to find the inverse of this. Okay, so what we're going to do first is let y equal 3x minus 5. Now guys, this is similar to what we was doing earlier. It's just that instead of just having x minus 5, we now have 3x minus 5. So what do you think we need to get rid of first?
5.
Lovely. We get rid of the minus 5. How do we get rid of minus 5?
Plus 5.
Plus 5 from both sides.
Good job. So we add 5 from both sides. So then we would end up with y plus 5, which is equal to 3x. What's the problem here now? We didn't cancel out the 3. Excellent. So what is our next job then?
Subtract 3 by 3x.
We divide by the 3. Because remember, The 3 is being multiplied to the x. So what's the opposite of multiplying?
Divide.
Divide. Good. So we divide both sides by 3. Okay? So when I put it like this, that's like me saying divide by 3. Alright? So then, as you said, this here would cancel out. Now, we are left with y plus 5 over 3, which is equal to x. How are we looking now? We good to complete this now? Is x the subject? Is the subject. So all we have to do now is say that f inverse, once we interchange again, we'll just say here is x plus 5 over 3. So really and truly, why we're putting it back as x as an x, because typically that's how we represent functions, having it expressed in terms of x. That's typically how we do it in most cases. So we just put it back in that form so it could be what we usually do. All right, so we have this one here now. So we do the same concept again. So we say let y equal gx. And then now y is equal to 4 minus 7x. Now, we want to get the 7x, the minus 7x by itself first. So what we're going to do here now, we're going to subtract 4 from both sides. So now that we did that, we will end up having y minus 4 is equal to negative 7 over x. Now, what do we do from here?
Cancel out the negative 7.
Excellent. We cancel out the negative 7. Alright, so we divide both sides by negative 7. Then now we actually have x by itself. So it's like we're saying y minus 4 over negative 7, which is equal to x. So now I could write the inverse of g. So g inverse x is equal to, interchange, x minus 4 over negative 7. And that's my answer. Alright, so now for y'all to try now, hx is 2x plus 8, and then 10 minus 3x. Alright, so let's go through these now. So we got this here now. So the same process. So we want to let y equal to hx. So since y is equal to hx, we could now say y is equal to 2x plus 8. Now we just need to get rid of this 8 first. So we subtract 8 because the opposite of adding 8 is minus an 8. So we will be left with y minus 8 is equal to 2x. So since y minus 8 is equal to 2x, now we could divide both sides by 2. Alright, so once we divide both sides by 2, we'll be left with y minus 8 over 2 is equal to x. So therefore, we could say that h inverse, if we interchange, would be equal to x minus 8 over 2. And that's it. So then on this case now, same thing. We say let y equal mx. So then we could say y is equal to 10 minus 3x. Now if you notice in this case now, the 10 is on this side and the minus is on that side. In the sense of that we have the x in the front like we did for these other questions. So remember now we just have to minus the 10 here from both sides to get rid of that 10. If it was a negative 10, we would have added 10. So then we say y minus 10 is equal to, this cancel out, so then we left with minus 3x. So now we can say y minus 10, since it's equal to negative 3x, we need to get rid of negative 3, which is being multiplied, so we divide it to get rid of it. So then we'll be left with y minus 10 over minus 3 is equal to x. So therefore, m inverse of x is equal to x minus 10 over negative 3. And that's our answer right there. So if you didn't have it, take it down and we go to the next level. The next level. Well, I'm taking you through a lot of the common different perspectives of functions. Okay, so we're going through that so you could better understand what it's all about through examples, and then you try it just to reinforce it. So then later on, I'll give y'all something to work on during the week where you will actually be practicing different functions questions. So fx, let's say now that we have x squared minus 5 as a function. So then the next function we're gonna have is g of x, let's say x plus 4 over 5. And we have a third one, h of x is equal to 11 over x minus 3. So we have three different functions here. As you can see, we have one almost in we have two in fraction form, and we also have one that involves a squared. Okay, so what we're gonna do is we're gonna go through this process and see how we can solve this. So for instance, in this case here, we do the same thing. We want to calculate the inverse. So what we say is, we say f inverse would be, we start off with y equal fx. So that's what we want to do. We want to let y equal fx. So then the next thing we're going to do is y is equal to x squared minus 5. Now, what's the problem here? Who is the first thing we try to get rid of in this question?
The minus 5.
The minus 5. So how can we get rid of the minus 5?
Plus 5 on both sides.
Say again?
Plus 5 on both sides. Add 5 on both sides.
So we add 5 on both sides. So then that will give us y plus 5 is equal to x squared. Okay? So then now, what's the opposite of x squared? What do we do to find the opposite of x squared?
Square root of x.
So we square root x squared. So this will cancel out, and we'll be left with the square root of y plus 5 is equal to x. So therefore, we can substitute back our interchange. So if the inverse would be equal to square root x plus 5. Make sense?
Yeah.
Alright. Now, this one here now, we do the same concept. Let y equal g of x. So then now we could say y is equal to x plus 4 over 5. Now the thing is with this, similar to what we did for one of the first examples, we have to make y kind of like a fraction. It's not a absolute must. There is a other process where you just multiply 5 to both sides, but the reason why I'd like to do it like this is to keep it standard for when we reach questions like this, which you will see in a bit. Okay, so let's go with this here now. So what we have here, we can say we cross multiply. So y times 5 and then x plus 4 times 1. So what we'll be left with is 5 times y is 5y, which is equal to 1 multiplied by x plus 4. So now 1 multiplied by x is x, and 1 multiplied by 4, positive 4 is positive 4. So 5y is here. Now we need to get the x by itself. How do we get the x by itself now?
We 4 from both sides.
So we take away 4 from both sides, which would leave us with 5y minus 4 is equal to x. So then we can interchange this again and say g inverse x is equal to 5x minus 4. All right. So let's look at this next one here now. So this one here now, we say the same thing. Let y equal hx. And then now we could say that y is equal to 11 over x minus 3. So if I was to write y as a fraction, same concept again, y over 1. So this is where I tell you that we did this like this. So now I'm cross multiplying, so y multiplied by this and 11 multiplied by this. So what we'll end up having is y times x minus 3, which is equal to 11 times 1, which is 11. So now I have to multiply this out. So y times x and then y times minus 3. This gives me xy, and then y times negative 3 is minus 3y, which is equal to 11. Remember, we need to get x by itself. So right now, what we have is the xy. So we need to keep that on that side because that's the only thing with an x on it. So we got to get rid of the minus 3y. So we just add 3y to both sides in that case. So that will leave me with xy. That would leave me xy is equal to 11 plus 3y. And then now we divide both sides by y. So we divide both sides by y. And that's what we left with. X is therefore equal to 11 plus 3y over y. So once we interchange now, we'll get that the inverse of h is equal to 11 plus 3x over x. Alright? So I want y'all to take that down, and then I'll give you some to try just like this. So these here are very straightforward. So to find the inverse of these, we would just say let y equal fx. So then we could say y is equal to x squared plus 11. So then we subtract 11 from both sides. We left with y take away 11 is equal to x squared. So then the opposite of this is just square rooting. That will cancel. So we'll be left with the square root of y take away 11 is equal to x. So we could then put it back. F inverse x equal square root x minus 11. Alright, so with this one here, we would say let y equal fx gx. So then we could say y is equal to x minus 3 over 4. So we put y over 1, cross multiply. So 4 times y is 4y, and 1 times x minus 3 is x minus 3. To get x by itself, we add 3 to both sides. So that will leave us with 4y plus 3, which is equal to x. So then now we could have our answer as g inverse x, which is equal to 4x plus 3. Now with this one here now, same thing. Let y equal hx. And we could say y is equal to 10 over x plus 2. Put this over 1, so we could cross multiply once we see it as a fraction. So y times x plus 2 is equal to 10 times 1, which is 10. Y times x, xy. Y times 2, 2y. So now we subtract 2y from both sides. So this will cancel. We're left with xy is equal to 10 minus 2y. So we divide both sides by y. We're left with x is equal to 10 minus 2y over y. So we know how we write our final answer. H inverse x is equal to 10 minus 2x over x. That's our answer. Alright, so y'all ready for the next level? Okay, so this one is gonna be irrational functions. So it's going to be like the advanced version of what we just did. So let's say we had a function f of x, which is equal to x plus 5 over x, let's say 2x minus 3. Alright, so what we're going to do here now is we say the same thing. Let y equal fx. And then we'll say the same process. Y is equal to x plus 5 over 2x minus 3. Now this is another reason why I was telling you guys that it's important for us to follow that process of cross multiplying where we put y over 1. So we have here y over 1 is equal to x plus 5 over 2x minus 3. So what we will do here now, y is going to get multiplied to the bottom here. X plus 5 is going to get multiplied to the bottom here. So then we'll end up having y multiplied by 2x minus 3, which is equal to 1 times x plus 5. Now this here is probably the toughest you would get this particular kind of question. Okay, so this usually comes on the last section if you get it, just to see how good you are at it. Alright, so y times 2x is 2xy minus 3y. Now how did I get that? I did y times 2x is 2xy, and y times minus 3 minus 3y, which is equal to 1 times x is x, and then 1 times 5 is 5. Alright, so then now what we want to do is get anything with the x by itself. So if you look at this here, remember this here is here will be the x's. So I just want to show you how we have the x here and the x here. So this is what I want to group together. I want to get these two together. So what I could do is I could get this x on this side, and then I'll bring this minus 3y over here. So I'll do it phase by phase so you could see each. So the first one, let's get this x over here. So right now this is a positive x. So we subtract it from this side, therefore, and we subtract it from this side. So therefore it's no longer there. Now we're going to have 2xy minus x minus 3y, which is equal to 5. So that's what left back over here. Alright, so now you can see my x's on both sides here, on the same side here, and then I have a minus 3y that needs to go because that's taking up what we're trying to do. So we add 3y to both sides. So then now we'll end up with 2xy minus x, which is equal to 5, and then now we added the 3y plus 3y. So I want y'all to take this down and we'll continue from there. Just want y'all to catch up with that, and then we go through that. Alright, so let's continue now. So we still need to get x by itself here. As you can see, it's like two separate things. So the only way we can do this is if we factorize. Okay, so when we say factorize, we want to bring this x outside. So in other words, we divide each thing here by x. So x into this will leave us with 2y, because essentially if I have 2xy and I divide it by x, the x's will cancel off and leave me with 2y. Now likewise, if I have this minus x here divided by x, x into itself goes once, and then here will be 1. But because we have minus 1, you'll have here minus 1, because minus 1 divided by 1 is minus 1. Alright, so that's how we get this part, which is equal to 5 plus 3y. So if you look at it, x is almost by itself, but it still has a problem. It's being multiplied to this 2y minus 1. So because of that, what we have to do is we have to now divide both sides by x, by 2y minus 1, sorry. So then this is going to cancel out, and we're going to be left with x is equal to 5 plus 3y over 2y minus 1. And you know what happens here? We then say that f inverse x, we interchange the stuff. We'll have 5 plus 3x over 2x minus 1. Alright, so I want y'all to try that. So I'll give y'all one to try. So minus 7 over, let's say, 3x minus 4. So I want y'all to take that down, and while you do this, I want y'all to take this down and try it. While y'all do this, I'll answer the questions before so you can see the answers. So make sure you take this down. I'll give you 15 seconds to write this down. Alright, let me go to this one here. Y'all finished with this? Still working on it? How are y'all getting through with this one? Alright, let's go through this now. So we say let y equal gx. So then what we will end up saying is that y is equal to x minus 7 over 3x minus 4. So we put this y over 1, cross multiply, so we'll have y times 3x minus 4, which is equal to 1 times x minus 7, which is just going to give us x minus 7. Anything times 1 is itself. So we multiply this out. So y times 3x is 3xy, and then minus 4y, which is equal to x minus 7. So then now we want to get the x's on one side and the rest on the next side. So we minus x on this one here to get it over here. Alright, and then I'll just get rid of this one time, plus 4y. So this will cancel, this will cancel. Alright, so then I'll have 3xy minus x, which is equal to, and remember I had to add the plus 4y here. Just add the plus 4y here as well. So this cancel, that cancel, and this is what's left. So then we'll have 3xy minus x equal minus 7 plus 4y. Alright, so then now we factor out the x. Okay, so we say x is a common factor here, 3y, and then minus 1. So when we work this back out, x times 3y will give us 3xy, and then x times 1 will give us minus x. So then that will be equal to negative 7 plus 4y. So then now we divide both sides by 3y minus 1, and we'll be left with x is equal to minus 7 plus 4y over 3y minus 1. So then I could write my inverse function g inverse x is equal to negative 7 plus 4x over 3x minus 1. And that's the answer right there. This normal 7, it can still be minus 7 because remember we left it as minus 7 here. You see the 7 was negative here? Yeah, so that's why we kept it here. Got it? So this one here is a little tricky one, right? So these ones come with practice. You got to practice these often to kind of get it to sink a bit, right? So I'll send you some stuff to work on at some point as well too. Yeah. So take this down for now, and then I'll show y'all one more aspect of functions, and we'll do the relative questions for that, and then that's it. Alright, so this is a new concept here, but it's very easy. Then 2 is going to be expression for the inverse of x. And then we're going to have third one here, 7. Is it 7 I want to put here? Yes, 7. And then 4, fx equal 7. Alright, so let's go through this. So when is gx undefined? So a function that's irrational is defined when the denominator is equal to 0. So in this case, basically, this is the denominator. Question is, when is this equal to 0? When would this be equal to 0? When x is what value? Lovely. When it's 3. So if we add 3 to both sides, we basically solve and would have x is equal to 3. So when x is equal to 3, here is undefined. So in other words, if x was equal to 3 and we put 3 here, it's going to say 3 minus 3 is 0. Once you divide any number by 0, you're going to get undefined. So 3 plus 5 is 8. 3 take away 3 is 0. So 8 divided by 0 would give you undefined. So it's when x is equal to 3. Next one. The inverse of this here. So we say let y equal fx. And so let's just jump to this part here because we know how to do this. We add 5 to both sides. So I'll be left with y plus 5 is equal to 3x. Then when I divide both by 3, I'll be left with f inverse x being equal to x plus 5 over 3. Now, for this part here now, what do you think I would do with this 7 here now?
Replace it with what?
Replace it with x.
X, yeah.
From this one. Good. So then now, for number 3, I would insert 7 into this here. So I'll end up getting 7 plus 5 over 3, which is equal to, which would basically go to 12 over 3, and that would be equal to 4. Alright, so then now this here now. So I want y'all to take this note down. Note well. Very important. Note well. So note well. If you have something like this, f inverse is the same as is. So if you know the answer for this, you know the answer for this. Because essentially, you're trying to figure out what the value here is, which is x. And this here would give you that value of x, right? So if you're given this question in this form, since fx is equal to 7, so from this, fx is equal to 7, all I need to do is replace fx with this here, which is 3x minus 5 equal 7. So now we could add 5 to both sides. Because remember, I'm saying that fx, or this function, is equal to 7 because that's the output. So now I'm trying to figure out what the input was. Okay, so 3x would then be equal to 7 plus 5. So then 3x is equal to 7 plus 5, which is 12. Divide both sides by 3. X is equal to 4. So it's literally like the same thing that happen here. Alright, so just for reinforcement, I want y'all to do a fresh one. Same concept. So 2x plus 3 will be your question, where gx would be x minus 5 over x minus 8. Let's say plus 8. And then 1, when is gx undefined? 2, get an expression for the inverse of f. 3, find the value when it is this, and then solve for the input of x when it's equal to 15. Alright, so I want y'all to work on this, and that's it for the day. And I'll just go through it with you just in case you didn't get it, so write that down and work on it. Okay, so let me go through it now. So the first one, number 1. Alright, so when is gx undefined? So when we say undefined, that means the denominator here needs to be equal to 0. So if we say x plus 8 is equal to 0, that means it's going to be when x is equal to negative 8. So that's the answer for the first one. Make sense? Alright, so let's look at the next one. When is gx undefined? I mean, when is the inverse of fx? So for that part, no. When we're doing the inverse of fx, what we'll end up saying is that we have the function. So what will happen is we have the function f of x right here. So we could say let y equal 2x plus 3. So we say let y equal 2x plus 3. So what we're going to do now is try to make this here the subject of the formula. So we minus 3 from both sides. So then we'll end up with y minus 3 is equal to 2x. Then we divide both sides by 2, and we will be left with y minus 3 over 2 is actually equal to x. So therefore, the inverse of x is equal to x minus 3 over 2. Does that make sense? Good. So then now the next one here. So with this one here, f inverse, we put in the input as 11. All we need to do is substitute this x with 11. So then we would have 11 take away 3 over 2. So we got that from this right here. So then 11 take away 3 is 8. 8 divided by 2 is 4. So our answer here is 4. Alright, so then the last one now. F of x is equal to 15. So we want to figure out what value of x would give us 15. So we know what fx is, 2x plus 3. So 2x plus 3 is equal to 15. So what we would say in that case now is, since we have that, what we would say is, we got the 2x plus 3, which is equal to 15. So then we're gonna end up subtracting the 3 from both sides. So minus 3 minus 3. So then we'll end up with 2x, which is equal to 15 minus 3. So then 2x is equal to 15 minus 3, which is 12. Divide both sides by 2, and then x will be equal to 6. Does that make sense? Alright, so I want y'all to take this down. I know we went through a lot today just to make sure we close off this section. So what I'm going to do is I'm going to give you guys some stuff to practice from as well. So take this down, and then, you know, that's it for the night. Genevieve, you got it as well too? Lovely. Did you try to do it? Did you get it while you were trying it? So all we got to do is clean this up through practice now. Alright,